Okay, so what I got here is really it's called example 2b because it's another version of how we're going to prove the base angles theorem, and it's going to be very similar, but it's going to be a different reason why it works. It's not going to be side 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 because we're given some different information. Now, instead of a median goes from a vertex to the opposite side's midpoint. We're going to use the altitude, which goes from the vertex to the opposite side, but instead we don't know where it hits the opposite side, but it does make a perpendicular or right angle. Okay? It's perpendicular to it or it's a right angle. So I wrote that definition there. I'm going to erase the altitude word just so that we can actually work in the triangle. But that's what the altitude is, so that's that version of it. Okay, so we've got that there. And the one thing they told us is that it's a isosceles triangle, and if it's perpendicular, we know that's a right angle. So let's go and prove this one again, and we're given again that AC is congruent to AB because it was given. And we still want to prove that angle B and angle C are the same. So we're trying to prove this again. Okay, that's what we're trying to prove. So when we do this, step one is the given. We know we get a set of sides. Okay? The other thing we get is this is shared. So we get AD, which is just like the last time, is congruent to AD because of the reflexive property. Okay, so that's no big deal, and so I'm going to put that's a side. And the last time we used another side, but we don't know anything about CD, and we don't know anything about BD. But we do know we have this right angle here. So we're going to establish that that's a right angle and see if that helps us in any way. So let's do that. So we know that angle ADC is a right angle. So let's change that. Angle ADC and angle ADB are right angles, the definition of an altitude. Okay? So if we have that, then we have a pair of them. And we're tempted to say that's, maybe we have SAS, okay? But we actually don't. We have ASS, and we don't want to be a Shakespearean donkey. So we got to go back to it. And this is where we get to use the special one. Because it's right triangles, so I'm going to get rid of this here. Let's not use that. Let's call it instead, let's call this AC and AB. Those are hypotenuse. That's one hypotenuse in each one of those triangles. And then AD is a leg. And so we can use that theorem to save us some time. And we can say number 4 can be triangle ADC is congruent to triangle ADB. Mess that up. by hypotenuse leg. Now that we know that that's true, we can say angle B is congruent to angle C, which is also proven the base angle theorem, by CPCTC. And we've proven it.